Let's look at the next methodology, and this one's called the incremental method. Probably a good place to start is on the word incremental, so let's go from there. Incremental means in a series of amounts, and I guess in this case it means increasing things in small amounts. And that might lead us into exactly how this works. The incremental is, to all intents and purposes, very similar to the waterfall method. It's a linear method, it's quite rigid, but it works in a slightly different way to the waterfall. So let's dig in and see how this actually operates. The most important thing to remember is that this is the waterfall method, so it works in a very similar way in that you start off with the initial planning down here, which leads to the requirements phase. Then you go on to the analysis and design, implementation, deployment, testing and evaluation. So in that sense this works very much in the same way as the waterfall method that we'd looked at before. But there is one key difference, and that is that it's done several times. So if you look at the screen and you've got build 1, build 2, build n, those builds refer to modules, and that's the key way in which this is different from waterfall, is that you take a project and you would split it into modules, or builds as they're called here, and then you would complete module 1 and you would add that to the system, and then you'd complete module 2 and add that to the system, and in this case do build n or module n and add that. So let's delve down a little bit more into this. If we look at build 1 that we've got here, if you're thinking about, let's think about an example that everyone understands. Let's look at building Windows 15. So building Windows 15, you'd put perhaps one team in charge of doing the windows and making the windows look different. So let's call that the Windows group over here. And then you might have another group looking after the icons. So build 2, that's going to be the icons group there. And maybe the pointers group would be group P there. So first of all, the W group, the Windows group, would go through this cascade, the waterfall method, and would first of all start at the requirement analysis over here, and then would go and do the design development here, would then go on to the testing, and then the implementation. And that would get added to the system and would be used and tested with the system. And then you'd start the second part and add each part one at a time, and you'd work through it in exactly the same way, and then you do the last part there. So this is similar in the way that it's delivered, but it's different because you're actually going to run this in 3 or more separate builds or modules. This might make more sense in terms of the modules, that here you've got module 1 and here you've got module 2. And usually the first module will be made, it'll be added to the system, and then the second module will be made, and that also will be added to the system once all the stages have been completed. So that in essence is the incremental model. If we look at the key points of this model, the first one is the fact that it allows a project to be split down into smaller parts, and each part is developed using the system lifecycle that we've looked at before. And of course we've established that it's built incrementally, hence it's called the incremental system, piece by piece. So once all of that's achieved, we then need to look at the advantages and disadvantages of this system. What sort of projects might benefit from a system such as this? If the requirements are clear and fixed, and this is exactly the same as for the waterfall, in fact it's exactly the same information. If the requirements of the project are clear and fixed, and they're known up front in the early stages, it's a good choice. Equally, the product definition, in other words, that what you want to do, the thing that you're looking to do, remains the same throughout the duration of the project. Again, that would be a good reason to use this particular methodology. Equally, the technology being stable, the technology being fully understood. If there's a chance of you getting surprises halfway through, wouldn't be a good choice of methodology because it's a very rigid system. Equally, same as for the waterfall, the idea that the expertise needs to be freely available as and when it's required. And because you've got all of these builds going on one after another, you might need to have a team sitting around and waiting, but you certainly need to have them available at the time that they're required. One of the bonuses here is that the project, this works better for a short project. Okay, let's look at the advantages now. Using this methodology means that you can generate software very quickly, very early in the cycle. It's more flexible than the waterfall methodology because you've got smaller iterations going on, and therefore it's less costly to change scope. I want to spend a minute talking about scope, and if we look at a simple diagram of a gun scope, which might be a bit like that, you can think of scope as being that which is in aim, that which is your focus. So when you talk about the scope of a project, you mean what it is that you are going to have to do. And when you write up your design, that is essentially your scoping document, that which you're going to have to do in the document. And everything outside that scope, well, that's irrelevant because you don't have to worry about that too much. And that's a key thing to remember on scoping, is that as long as the scope doesn't change, this is a good choice of project. But equally, if the scope does change, it's a better choice of project management system than, for example, the waterfall. But still, there are better systems if the scope is likely to change over the course of the project. It's easier to debug. It's easier to debug than waterfall because the iterations are smaller. So therefore, it's easier to find problems and it's easier to put them right. It's also easier to see risks in advance because the iterations are smaller and therefore easier to manage than in the waterfall system. Comes with its disadvantages, which are again very similar to the waterfall system's disadvantages. It's a rigid system, the phases don't overlap, so you have to go back stages if something goes wrong. But there's an additional issue which is particular to this methodology, and that is the way in which it is actually designed. Now let's go back to this slide here, and let's get rid of the lines all over it because we don't need those. But if you imagine, we talked about this being a Windows product where you need to have build 1, build 2 and build 3, all right? Will you imagine that you've put build 1 in place, it's all working absolutely fine, and then you put build 2 in place and it's absolutely working perfectly, but then when you put build N in, it turns out it doesn't actually work that well with build 1, which means that you then have to redo build 1, which could lead to having to redo build 2 as well. And by the time you get to that, build 3 might not work. So when it talks about architectural problems, it means that what you've already laid down may subsequently be found to be not useful or to need significant change. And that's one of the key areas that you need to focus on when you're choosing which methodology you're actually going to use. So we've talked about the advantages, we've talked about the disadvantages. This is another version of the waterfall methodology, but it's one that's slightly more flexible, but again is only useful for a certain type of project.